So since this one so nicely juts right up against the y-axis, I could have actually done this with respect to y. The only difference is that my equation currently is y equals, and if I'm going to do it with respect to y, I need x equals. And the other equation already has an x equals, so if I wanted this to be x equals, of course I could multiply both sides by x, and then divide both sides by y, and voila, I now have that also in x equals. And so now I'd be looking at the right minus the left, and the boundaries would be, since this is going to be dy, so the boundaries for y are the lower boundary, which is 1, and the upper boundary, which is 4. Now, if you turn your paper sideways or turn your head sideways and you look to see what's the right curve, well, from purple to purple, the only curve I have now is just this one curve, which is the 4 over y. And the left curve from purple to purple, from bound to bound, is just the x equals 0. So I'd be subtracting 0. These are both x equals. And so now I don't have to worry about piecing it up because I didn't have the issue I had when I was doing it with respect to x, where the upper curve, dependent upon where I was, the upper curve was either this or this. I don't have to worry about that now because the upper curve is all the red. It's all the same curve. Okay, so pause the video. Of course, I don't need to have this in here. If I simplify, that'll be gone. So pause the video and take the integral and see if you can get the value. So first of all, there's your integral. And now I'm going to plug in. And so I'll have 4 natural log of 4 minus 4 natural log of 1. But everybody knows natural log of 1 is 0, so this is all going to go away. And I end up with 4 natural log of 4, and OMG, that is the exact same answer I had when I did it with respect to x. The question that I'm going to pose to you is, which version was easier? Was it easier to do it with respect to x, or was it easier to do it with respect to y? Okay, see you back in class tomorrow.